Assalamu alaikum everyone, and today we are going to see the scientific notation and dimensional analysis. First off, you see some people say numbers like this: 1 times 10 to the 6th, or 3.4 times 10 to the negative 8. Have you ever heard these type of numbers before, or anyone saying them? Well, these are referred to as scientific notation, which is sometimes important for math, but mostly important for science, mainly physics and chemistry. It says a number, it can represent a number really big or really small. Suppose you want to calculate the amount of cells in a person. That number would be very big, like 35 trillion cells, and also very hard to write since there are all these zeros. But if you want to take one of the cells and take the length of the diameter and calculate it in meters, you'd get something very small, around 0.0000005 meters. So we can use scientific notation to make them easier and write them faster. This is how it goes. Suppose I'm going to take this. Let's suppose I'm gonna write a number. Let's say 125 million. 125 million. To do scientific notation, or write it in scientific notation, we have to do something very specific. First off, we have to cancel one of these zeros, or reduce one of these zeros. So by that, the number gets 10 times smaller. We don't want the value to decrease, we just want to write them in scientific notation. So we add, actually let me clear up this space. So we multiply, we can give here multiply by 10. Then we decrease another 0, making the value even 10 times smaller. So this would be referred to times 10 times 10. But wouldn't that make a mess? This part is getting really simplified, but this part is becoming a whole mess. We can solve that by exponents. We can simply write 10 times 10 as 10 squared. Now things are looking simplified. So now we decrease by 10 here again, and increase the 10 here to keep the value same. Times 10 to the third. Then we do this again same way as usual. And we increase the exponent because this part is decreasing by 1 power of 10 or dividing by 10 at each time. So we need to increase the exponent. Now let's say we decrease it here and increase it here. 5. Then 125. Now it's decreased a lot, so we increase here. Now we're gonna get to decimal parts. Actually, let me write 12.5 times 10 to the 7. Now we decrease by 10 again, so we increase it. And now here is where we end our decreasing digits. We have to at least have 1 units digit. There can be as many decimal digits. Whew, that was a long one. But this and this is equal for the scientific notation. Now we write it in scientific notation for more or less. The exponent defines the order of magnitude. So if we want to compare things during scientific notation, comparison, greater than, less than, equal to, we need to see its order of magnitude. That's the first priority. So this number compared to, let's say, this number, this one is greater for its order of magnitude. So now we have a good understanding of scientific notation. Let's see dimensional analysis. This is just nothing. This is just observing the metric system again. Kilo, suppose, is 10 to the 10 cubed, basically. So if you have something like 100 kilograms over 10 kilograms, you can cut these here because this will be the same as 100 or 10 times 10 cubed grams times 10 cubed grams, all these stuff. So we can cut these for common factors. So you can see that, and that will be the scientific part, the thing that would be important. So as we can see, this was a really tough one, but I hope you got it. If I missed anything, you can leave it in the comment section below. You can subscribe for more of these videos. And thank you for watching, and I'll see you next time. Bye!